Hey everyone, this is Micah coming to you guys live from over here. Just wanted to take some time to go over, some of the things that we talked about last time in regards to some basic rules. We're going to go over some examples that basically recap those rules that we discussed in the first video. Like the law, we're talking about subtracting, adding fractions, and then also, you know, multiplying and dividing fractions as well. So the first problem that we are going to go over is very simple. It has to do with subtracting fractions. We have 27 minus 35 divided by 4. So what we want to do in this instance is first split that fraction in half in regards to the numerator. So you're going to take the 27, you're going to put that over here. 27 over 4. So we're going to keep that group together. Keep in mind that the denominator can be split. So the denominator is going to be the same even though we split the fraction apart. So it's going to be 27 minus 35 over 4. So what you want to do is go ahead and just subtract that through. It's very super simple. 27 minus 35 is going to be negative 8. And then you just want to carry over the denominator. That does not change. So that's literally the answer to that one. It's just that super, like I said, super simple. Next one's really easy too. We have 6 over 7 minus 4 over 7. It's basically, we just fast forward to this step. We don't even have to split the fraction apart. It's already done for us. So we all know what 6 minus 4 is. It's 2. And the denominator stays the same. So not going to spend too much time on that one. Then we have number 3. Number 3, we have 10 divided by 11 plus 6 over 33 minus 13 over 66. So this one's slightly more complicated. It has a little bit more steps, but not too bad. All we're going to do is basically what we're going to multiply through. So we're going to go ahead and use that law when it comes to adding fractions. They do not have the same denominator, but keep in mind what we want to do is have everything in the bottom. Yeah, what we want to, our goal is going to be to have all of these be the same. So let's see. What you want to ask yourself is, what can I multiply 11 by and 33 by? So that they are equivalent to 66. So that's what we want to do. So what you want to do over here is go ahead and I'll open up another sheet. Hold on. There we go. So what we want to do is just have the 10. We want to just have the 10 over 11. We're going to put that by itself. And then we're going to have that in addition to kind of give myself some space, the 6 over 33. Going to group that together. And then lastly, we're going to have that 13 minus 6, over 66. So, if you take so basically you want to ask yourself, what can we multiply times 11 to get 66? You could just divide 66 by 11. That's going to give you 6. Same thing if you do, in regards to trying to find a number that would make 33 equivalent to 66. If you take 66 divided by 33, you get 2. So what you want to do is multiply everything in the parentheses by 2. That's going to transform both of these fractions into denominators that are equivalent to the 66. So 6 times 10, we'll just go ahead and kind of show an arrow so that we're going down. 6 times 10, that's going to be 60. So we're going to have 60 over 66. Then we're going to go to the next fraction. 2 times 6 is 12. And then 2 times 33 is 66. And then we can just go ahead and carry the 13 over 66. We can just actually bring that right down. That is a huge subtraction sign. Getting kind of heavy-handed with these bars. Here we go. All right. All right, so the last step is we want to go ahead and just add and multiply everything through. So we just want to go ahead and take 60 plus 12. So 60 plus 12, that's going to be 72. So 72 over 66. And then we have, just bring down the 13 over 66. And then you just want to subtract it through. We're going to have 72 minus 13, which is equivalent to 59. Therefore, our final answer is going to be 59 over 66. Okay, so that one, like I said, pretty straightforward in regards to doing that one. It's just remember, as we go on, we're going to start combining all these rules that we learned, and I'll spend the next video recapping that a little bit. So let's jump back to where we were. We just did number 4. Wait, was that? No, that was number 3. So what we can do is go ahead and hop here onto number 4. Number 4, basically, we're going to use the dividing rule, dividing fractions rule. We have 11 over 16 divided by 3 over 4. Pretty super simple. We're just going to take the 11 over 16, and we're going to flip that 3 over 4. So that's just going to turn into, that's a multiply, well, this multiplication sign. We're just going to multiply that times 4 over 3. And remember, we just multiply everything across. So it's just that easy. It's going to be 11 times 4, which is 44. And then we're going to take that and do the same thing with the denominator. 16 times 4, 16 times 3. 16 times 3, which is 48. And then what we can do finally is take this down to its lowest term. So if we divide both the numerator and the denominator by 2, we know that that is a common factor that they have. So 44 divided by 2 is going to be 22. You can simplify that. Then 48 divided by 2 is going to be 24. And then looks like we can simplify this even further. We can actually divide each of these numbers by 2. So 22 divided by 2 again, it's going to be 11. And 24 divided by 2 is going to be 12. It looks like these don't have any numbers that can be divided by each other in common. So that's it. I'm going to do 2 more, and then we'll call it a wrap for this time around. The 5th problem that I wanted to look at was this one right here. We have 12 divided by 1 over 4. This can be a little tricky sometimes because if you see, we're dealing with a whole number, that being 12, and then a fraction on one side can be kind of tricky. But just keep in mind, when you do see a whole number, all you need to do is just remember that a whole number is just itself over 1. So that's any whole number, whether it's 100 to infinity. Any number that you see, if it's just it's just by itself, you can just picture that number being divided by 1, because that would once again give you that number, because 12 divided by 1 is just 12. So what we can do is just go ahead and use that for our purposes right here, 12 divided by 1. And then remember, we're dividing that by 1 over 4. But we want to go ahead and actually flip that. So we want to actually take that fraction, invert it, turn that into 4 over 1. And if you remember, the rule for division is that once you do that, you can just multiply everything through, which makes this problem really simple. At this point, it just turns into multiplication. So this would turn into multiplication. We're going to take 4 times 12, which is going to be 48 over 1. 48 divided by 1 is just 48. So super simple. Now, last problem is a little bit more tricky. We have a combination of steps. So I'll pause briefly and I'll let you guys kind of take a look at that, and you guys can figure out which steps we may need to go ahead and proceed with that and which rules we'll use. So give you guys a couple seconds, pause the video, and then we'll go from there. All right, so hopefully you had a chance to pause the video and to kind of take a look at the rules that we went over last time. So I'll go ahead and let you know. So what we're gonna actually need a couple rules. One of them that we didn't actually mention, but I mean it's prevalent in math. I like to call it PEMDAS, order of operations, most commonly known by everyone else. So a lot of people remember this acronym by the "Please excuse my dear Aunt Sally." That's how I was taught in school. You always want to do your parentheses, your exponents, multiplication, division, addition, and subtraction in that order when you're doing any kind of equation or solving any kind of equation to make sure you get the right equation, well, the right solution. In this case, we want to do parentheses first. That's why that's important. And if you notice, we are actually going to be dealing with not only division, but multiplication as well. And we have subtraction. So what we'll do, let's open up this other window I had over here. Here we go. We had this other window. Yeah, we'll use this window. For this problem. So we'll start off by going ahead and just like we did in the I think it was problem number the previous problem number 5. So we have 3 over 5, and we have that divided by 3, but we want to go ahead and just remember that 3 by itself is the same exact thing as 3 over 1. Put that in parentheses. And then I'll take the other side of the equation. We had 6 by itself, so we can do the same thing with 6. We can put 6 over 1 and then multiply that by 4 over 8. Okay, so that's the first step. The next step we want to do is go ahead and take that fraction that we have for that 3 over 1. Remember that we're going to have to invert that. So, and that just means that we're flipping it. So we have 3 over 5. We're going to multiply that times 1 over 3. And on the other side, we can go ahead and just multiply that through. That's super simple, super straightforward. We have 6 times 4, which is 24. And then we have 1 times 8, the denominator, which is just 8. So gives us one step closer to where we need to be. And then if we go ahead and just multiply this through, we have 3 times 3. Excuse me. We have 3 times 1, which is 3. And then we have 5 times 3, which is 15. So that's going to end up being 3. Actually, you know what? Let's just kind of keep things going the way that we've been going. That way it all flows down. Easy to kind of see what's going on. So we have 3 over 15 minus 24 over 8. All right. And what we want to do next is use that rule in regards to subtracting fractions with unlike denominators. So that's what we talked about in the last video. If you want to pause and look back at that video, this might be a good time, but I can still recap it. Just keep in mind that the law states that A over B minus C over D is equivalent to A times D minus B times C. And then we're going to take that and divide all of that by B times D. Okay, so that's the rule that we're going to be using here to solve this equation. So if we want to go ahead and just we can go ahead and use this right now in this bottom space and group everything together. So we have A, which is going to be 3, times D. Oops. So 3 times 8. And then we're going to have that minus 15 times 24. And then we want to take all that, divide that by B times D. In this case, it's going to be 15 times 8. Okay. All right, so let me just clear this really quick. All right, so once we go ahead and if you went ahead and solve that out, you should get 24, because 6 times 8 is 24, minus 15 times 24, which is 360. And then we're going to put that over 15 times 8, which comes out to be 120. Now, once you go ahead and subtract this, 24, you might need your calculator. 24 minus 360, that actually comes out to be 336. And then keep in mind that's going to be negative because 360 is greater than 24. 336 over 120. And if you look at these two, these are both even numbers. So when you have two really big even numbers at the end of a problem, 9 times out of 10, you're going to be able to extract the greatest common multiple and divide each one by that number, and then be able to take the fraction down to its lowest form. So in this case, if you divide 336 by 24, you get 14. And if you divide 120 by 24, you get 5. All right, so if you take these two, you bring that down there, you will end up with 14 over 5. All right, so that's our final answer for the last one. I'm going to do some more. My next video, I'll probably do some more problems from this chapter if I can find some. If not, we'll go ahead and go on to the next chapter. I might recap. But be that as it may, I appreciate you guys taking the time to watch this video with me. Please subscribe. Please like my videos. And yeah, also, if you ever need any help with any kind of tutoring, I do have the link to my actual tutoring page on my channel, so check that out, and it should be in the description as well. Any questions, feel free to reach out, send me a message. But like I said, thank